This is part 8 in a series of videos in which I'm attempting to repair this HH Tiger computer. In the videos so far I've gone through an issue and resolved an issue with the power supply, speculated that some major damage was caused to a lot of components on the main board because one of the video cards was inserted offset. That's kind of confirmed by when I tested the video RAM chips on that particular board. Every single one had failed, and I assumed all the rest had failed on the other two cards, but that may not now be the case. I've replaced all the devices on that particular card, and there were a couple of other ICs on that card that had failed as well. I think I showed one in the previous video. In the previous video I was going through with the logic comparator, testing the devices one by one, and I did find quite a few failed components. There were a handful of standard logic devices, so there was just a few of those, nothing like on the HP calculator that I did. The DMA controller had failed, the Z80 CPU had failed, and unfortunately the video controller chip has mostly failed. It is generating sync signals, but it won't communicate with the host's CPU. From that point on I was trying to figure out why there was nothing really appearing on the monitor. I mentioned previously I was getting a cursor, but it was kind of a ghost cursor. It seems as if though, because of the way the architecture of this machine is configured, even if you pull out all three cards, that kind of still appears, and I think it's just an artifact of the way this thing is put together. So there wasn't really anything scanning these video RAM cards and putting anything onto the display. Now initially I thought that the 6809 side was booting properly. It seemed to be going through all the motions, and when I booted up it was configuring the indicator lights the way it should. If I took the ROMs out, that didn't happen, so I was assuming this was booting up to a certain degree. I tried new PIAs, that made no difference. The Z80 also seemed to be booting up. It was doing something, but I'm not quite sure even now exactly how this thing is arranged. It appears as if though the Z80 is responsible for configuring the video controller chip, and the 6809 seems to be responsible for sending video data to the RAM through the video controller chip. So there's some load balancing going on here, and it's quite difficult trying to figure out exactly which bit is responsible for what part of that. So after I'd gone through and replaced all the faulty chips using the logic comparator, I started going through with a scope trying to trace through what was going on and what wasn't working. And it turned out that although there was activity on the data bus, which of course there always is, this wasn't coming directly from the 6809. So it appeared that the 6809 wasn't even trying to write to the video controller chip, and this chip had failed. Now I didn't have one of these, but I had an equivalent, and one thing I will be doing fairly shortly is posting a video about finding alternates and equivalents for these old devices. There's nearly always an alternate device you can use, and I happen to have some suitable alternates, so I put one of those in. Once I'd done that, the 6809 came to life, and it actually started communicating with the video controller. What I got on screen then, I'll show you in a few minutes, was just a grey background, and that was from each of the three planes, so I could do one plane at a time, and I was getting output from all of them. But I wasn't quite sure if anything was reading and writing to the memory. Well, I still wasn't getting anything other than the grey background. There was no text. I couldn't get anything to appear unless I induced noise. So I had the option of, well, is this a video RAM issue? I didn't really want to pull all the RAM chips out. I started to believe that the rest of the RAM chips were fine. So what I did is I took one RAM chip out. Now if you do this on a working RAM card like this, what you'll end up with is lines on the display, because obviously the pixel or the column or the row that is meant to be presented with data from that particular device won't be there, so you either get a dark or a light line across or up and down the screen in that position. But it will at least show if the video RAM is being correctly scanned. If it makes no difference at all, then chances are the video RAM isn't doing what it should be doing. And the way this essentially works is you have some shift registers, and the contents of the video RAM chips are loaded into the shift register, and then that data is shifted out to the display as the display is scanned. And this has got 3 planes that do that at the same time. So that causes an artifact, a consistent artifact on the display, if that is indeed what's going on. So what I'll do, I'll boot this up. You can see it's booting up fine, and I'll now move the camera so you can see the screen, and you'll see how far I've got with getting this to actually show some life. Okay, so as you can see on the screen, what I'm getting now are the vertical lines I was expecting, because I've removed one of the RAM chips in one of the cards, and that's to be expected. As I say, what I'm doing here is generating a composite signal from the RGB outputs of the system. If I disconnect one of those, you'll see that what happens is we get a change in contrast. The monitor's compensating for this, but what I've done is removed one of the channels. If I remove a different channel, you'll see that again the contrast changes, and put it back on and the contrast is back. So this proves that the video memory is being scanned by the video system, and it's outputting data that is stored in the video chips. It doesn't guarantee all the chips are working, but what it does do is show that that video subsystem is now working. And as I say, that was just really down to an issue with the SRAM in the 6809 side of the system. There were a few other minor faults as well, but that was the basis of it. That's what was causing the main problems. So we'll look back at the board. Okay, so from this point I know that the video subsystem's working. I know that the 6809 is booting up to quite a large degree, but there are some other memory chips down here. I'm not quite sure what they're for. But one thing that I found is that we just looked at the screen and we saw the vertical line, so we know that the video system is scanning. But it does exactly the same thing if I unplug the DMA controller, and it does exactly the same thing if I remove the DRAM from the Z80 side of the system. So although the Z80 seems to be actually running, it isn't. As I say, if I remove the DRAM, it makes no difference whatsoever to the behaviour of the system, and that leads me to suspect, of course, that the DRAM is faulty, or there's something preventing the Z80 from running. I've gone through all the usual checks. It's not been held in reset. All the data lines, address lines seem to be free and toggling, but it's just not running. I've tested the ROM again. I've even tried a substitute ROM with the code in it, and it makes no difference. I've tried a different PIO, I've tried a different Z80, different DMA, makes no difference. So what I'm going to do now is swap out the DRAM. Now, I don't have this type of DRAM in stock, but I do have some equivalents. Not exactly equivalents, but they are suitable alternatives. As I said, I'll be posting a video fairly soon as to how to go about determining if you can use an equivalent, and that's what I'm going to do here, because I have some that will work in this application. So I'll just swap these out and then see if that gives us any progress and boots the system any further. Okay, so I've swapped out the DRAM chips. Got a nice new set. As I say, they are different type, but they are pin for pin and operationally equivalent, so they should in theory work in this application. I've checked everything else. I've left the device out of the RAM card just so we can see if there's anything on screen, then whether or not it's reading all the cards and reading all the chips. So I'll try and boot it up. Okay, what I'll do is I'll move the camera so you can see the screen. Okay, I don't know how clearly this is coming out on the camera, but we're now getting the boot up text appearing, which is obviously an extremely promising development. We're still getting the vertical lines, of course, because the IC on the video RAM card is still removed. We're getting a lot of noise on here because of course this is not the correct way to feed this data into the monitor. What I'll do is reboot the Tiger so you can see what happens at startup. So as you can see, it writes the data to the screen. It appears to be the correct boot up text. If you can't read it, it just goes on about the need to run Tiger set, and I think that's because the CMOS ROM battery has been removed, and of course it's lost all its settings. Then it's asking for a system disk, and press return. So as I say, it's a big step forward. We'll look back at the Tiger now. Okay, so obviously we've made a big step forward. The system now boots to a large degree. Well, what I'll do next is refit the missing video RAM chip, see if that cleans up the display, and if it does, I'll reconfigure the display output so it's connected to the monitor in the correct way. The composite interface has done its job. It's allowed me to do the fault finding I wanted to, but now I want to see if the three pixel planes actually work the way they should. What I can also do now is go through and replace some of the parts that I've intentionally left off. One of those, of course, is the CMOS backup battery, and I think I mentioned in the previous video this looked like an iCAD, so I tried to charge it a week or so ago and it seemed to accept charge, and it is now still charged up, so it does appear that this is still a viable battery. I'll put this back on. I don't believe it's the original. This is not showing any signs of leakage, whereas there's a lot of damage on the board. But if you do buy this off the owner, then I suggest that you replace this at some point with a new one. But it is working for now, so I'll refit that. All the other devices that I've tested, I've obviously replaced any faulty ones. Once a system is up and running and I've tested the video completely, I don't know if all the video RAM chips work, so I'll test all those. Once I've done that, I'll look at the various interfaces. There are a lot of interfaces on here. I don't have a way to properly test all of them, or at least not with within a reasonable amount of time. So what I'll do is just check that the interface ICs are being properly addressed, and I'll respond in the way that they should. But that's as far as I'll go with those interfaces. The rest of it I'll obviously go through and test in a bit more detail. I'll reconnect the keyboard, see if that's working. There are some odd things going on with the keyboard. I mentioned in the previous video there are some missing tracks, and I'll see what's going on there. So in the next video hopefully we'll have a much more functional machine to look at, and once this is all done I'll tidy up the case, get the thing reassembled, and that will be this project complete. But a little way to go yet, but of course this is a big step forward, and it does now look like we can actually get this machine up and running.